1. Introduction to OOPS, Object-Oriented Programming, Concepts in Java. Object-oriented programming is a programming paradigm that uses objects and their interactions to design applications and computer programs. Java is an object-oriented programming language, meaning it uses objects and their interactions to design applications and computer programs. In Java, an object is an instance of a class. A class is a blueprint for creating objects. Object-oriented programming in Java uses the following concepts. Encapsulation, the practice of hiding the internal state and behavior of an object from the outside world. Inheritance, the ability for one class to inherit properties and methods from a parent class. Polymorphism, the ability for one object to take on multiple forms. Abstraction, the practice of only showing essential features of an object and hiding the implementation details. 2. Classes and objects in Java. In Java, a class is a blueprint for creating objects. A class defines the properties and methods that an object of that class will have. An object is an instance of a class. Objects have properties and methods that are defined by the class. To create an object, you use the new keyword followed by the class constructor. A class can have multiple objects, each with their own state and behavior. Example. In this example, dog is a class that defines the properties breed and age and the method bark. The object myDog is an instance of the class dog and it has its own values for breed and age and it's able to call the bark method. 3. Inheritance and polymorphism in Java. Inheritance. Inheritance is the mechanism by which one class inherits properties and methods from a parent class. This allows for code reuse and a more organized class hierarchy. In Java, a class can inherit from only one parent class using the extends keyword. The subclass inherits all non-private properties and methods from the superclass. Example. In this example, dog is a subclass of animal and it inherits the properties name and age and the method eat from its superclass. Polymorphism. Polymorphism is the ability for one object to take on multiple forms. In Java, polymorphism is achieved through method overriding and interfaces. Method overriding allows a subclass to provide a specific implementation of a method that is already provided by its superclass. Interfaces allow a class to implement multiple behaviors. Example. In this example, dog and cat classes are both subclasses of animal and they both override the makeSound method of the superclass to provide their own implementation. Therefore, when we call the method makeSound on dog and cat objects, it will produce different sound. 4. Encapsulation and access modifiers in Java. Encapsulation. Encapsulation is the practice of hiding the internal state and behavior of an object from the outside world. In Java, encapsulation is achieved through the use of access modifiers. Access modifiers control the visibility and accessibility of class properties and methods. There are four access modifiers in Java. Public class, method or variable marked as public can be accessed from anywhere. Protected class, method or variable marked as protected can only be accessed within the same package or by a subclass in a different package. Default, no keyword class, method or variable with default access can only be accessed within the same package. Private class, method or variable marked as private can only be accessed within the same class. Example. In this example, the class encapsulation example has three properties, name, age, and essay. In this example, the class encapsulation example has three properties, name, age, and salary. The name property has private access, the age property has protected access, and the salary property has public access. As well as the class has three methods, printName, printAge, and printSalary, which has the same access as the properties they are related to. Therefore, the name property can only be accessed from within the encapsulation example class and the printName method. The age property can be accessed from within the same package and by subclasses, and the salary property and the printSalary method can be accessed from anywhere. Encapsulation is useful to prevent direct modification of the internal state of an object by external code, which can prevent bugs and maintain the integrity of the data. Lari. The name property has private access, the age property has protected access, and the salary property has public access. As well as the class has three methods, printName, printAge, and printSalary, which has the same access as the properties they are related to. Therefore, the name property can only be accessed from within the encapsulation example class, and the printName method, the age property, can be accessed from within the same package and by subclasses, and the salary property and the printSalary method can be accessed from anywhere. Encapsulation is useful to prevent direct modification of the internal state of an object by external code, which can prevent bugs and maintain the integrity of the data. 5. Interfaces and abstract classes in Java. Interfaces. An interface in Java is a collection of abstract methods without a body. A class that implements an interface must implement all of its methods. Interfaces are used to define a contract that a class must follow. A class can implement multiple interfaces. Example. In this example, the interface drivable defines the method drive that any class that implements it must provide an implementation for it. The class car implements the drivable interface and provides its implementation for the drive method. Abstract classes. An abstract class in Java is a class that cannot be instantiated and is meant to be subclassed. An abstract class can have both abstract methods without a body, and concrete methods with a body. An abstract class is used as a blueprint for other classes. A class can only extend one abstract class. Example. In this example, the abstract class shape has an abstract method getArea that the subclasses must provide an implementation for it, and a concrete method draw that already has an implementation. The class square is a subclass of shape and it provides its implementation for the getArea method. Both interfaces and abstract classes are used as a way to define a contract that a class should follow and can be used to achieve polymorphism. However, interfaces are used when the implementation is not important and the only thing that matters is the behavior of the class, while abstract classes are used when there is a common behavior among subclasses and it's important to share some implementation details. 6. Constructors and initialization in Java. Constructors. A constructor is a special method that is used to initialize an object when it is created. Every class has at least one constructor. If a class doesn't have any constructor explicitly defined, then the Java compiler will provide a default constructor with no arguments. Constructors have the same name as the class and do not have a return type. There are two types of constructors in Java. Default constructor, a constructor with no arguments. Parameterized constructor, a constructor with arguments. Example. In this example, the class dog has two constructors, the default constructor and the parameterized constructor. The default constructor sets the initial values for the breed and age properties to unknown and 0 respectively, while the parameterized constructor takes in two arguments, breed and age, and assigns them to the respective properties. Initialization. Initialization is the process of giving an initial value to an object's properties. Initialization can be done using constructors, instance initializer blocks, and static initializer blocks. Instance initializer blocks are blocks of code that are executed when an object is created. They are usually used to initialize instance variables. Static initializer blocks are blocks of code that are executed when the class is loaded. They are usually used to initialize static variables. Example. In this example, the instance initializer block is used to initialize the breed and age properties with the default values when an object of the dog class is created. The values are assigned before the constructor is executed, and if the constructor takes arguments, then the values passed to the constructor will overwrite the default values. In summary, constructors are used to initialize an object when it is created, and the initialization is the process of giving an initial value to an object's properties, and it can be done in multiple ways.